This is the question that I posed at the end of the previous part of this video lecture, and let's go through these items one by one and see whether we believe that they are extensive. So, if one house is 200 square meters and the other house is 250 square meters, we would certainly expect that the floor area of the system would be the sum of those 450 square meters. We certainly expect that floor area should be extensive. Similarly, if there were, say, 20 kilograms of cats in one house and 30 kilograms of cats in the other house, then I think you see that it makes sense that the system's inertia of cats would be the sum of those 50 kilograms. That's extensive as well. And if the cats in one house eat 500 milligrams of food in a day and the cats in the other eat 600, then I think it's clear that the total for the system would be the sum of those 1.1 kilograms. That's extensive as well. The quantity you might have the most trouble with would be cat density. Students often have difficulty with densities, or indeed any quantity that's a ratio, so let's go through it in detail. Suppose one house has 4 cats in it and it's 200 square meters, and the other house has 5 cats and it's 250 square meters. You can do the division and hopefully see that the cat density in each house is 0.02 cats per square meter. Well, if this was extensive, then to get the total cat density for the system, we would add those together and get 0.04 cats per square meter. But that doesn't make any sense. For the system, we should take the total cats and divide by the total floor area of the houses, and that gets us 0.02 cats per square meter, not the sum of the two. So that's not extensive. And hopefully you can easily see that if the temperature in one house is, say, 22 degrees Celsius, and the temperature in the other house is also 22 degrees Celsius, it makes no sense for the temperature of the system to be the sum of those, 44 degrees Celsius. Temperature is not extensive. One of the reasons extensive quantities are so useful and powerful is that there's what you might think of as a simple accounting system for them, which applies to all extensive quantities. So, continuing with our cats, and if you think about the change in the number of cats in our system of 2 houses, there are only a few ways that the number of cats can change. A cat could come in from the outside. It could be adopted or bought, but in any case, we're talking about a cat that used to be out in the environment, which has entered our system of 2 houses. So far, our change is just the number of cats that come in as input. However, cats can also leave the houses, go from the houses out into the environment, and so we would call this output. But those aren't the only processes that change the number of cats in our houses. There is, of course, a process whereby cats are created, and so we have to account for that. And regrettably, there's also a process whereby cats are destroyed. So overall, between 2 times when we count up the number of cats in the house, there will be a change, and it has to be the input minus the output plus the number created minus the number destroyed. And this basic idea of input-output creation and destruction applies to any extensive quantity. Sometimes there are reasons to suspect that there are constraints on how changes happen in a system, and this can further simplify the accounting. So, for example, we might set up a situation so that input and output of cats in our system is impossible. If that happens, now our change between 2 times in the number of cats in our house is just going to be creation minus destruction. Similarly, we could have a situation where, I don't know, maybe we have neutered immortal cats, right? Sure, why not? That could happen. So if that happened, now creation and destruction are impossible. And so our change in the number of cats in the houses would just be the input minus the output. This last situation turns out to be a really important one for physical quantities. because it turns out we often have physical quantities that apparently can't be created or destroyed. And so we give this situation a name. In this case, where we have this quantity n, and we think creation and destruction are impossible, we would say that n is conserved.